Okay, this review, it says at the top, test over chapter 7 and 8, but it's actually over chapter 6 and 7. So, below is the regression output to predict the airfare in dollars. So, a lot of times as you read stuff, boy, that board is off, so give me a second to... All right, predict the airfare in dollars. That would mean airfare is Y from the distance flown, distance is X. All right, is a linear model appropriate? Anytime you're asked that question, and I'm going to talk loud, make sure it gets on there, but it picks up pretty good. That mic's pretty good. But you're supposed to look at the residual plot. So we look over here and we determine if the residual plot is roughly random. Now, just because there's more over here and fewer over here, that doesn't make it not random. I would say there's no clear pattern. So is the linear model appropriate? This I would make 2 points. And first of all, you would say yes, because the residual plot is random. Okay? If it wasn't random, if it had some sort of pattern, some sort of curve, then you would say no, a linear model is not appropriate. Okay? Because the residual plot is curved. Write the equation. So remember, there's a lot of extra stuff that we're not going to use till a later chapter. All this stuff, standard error of the coefficient, t-ratio, probability, none of that's going to be used. R squared adjusted, we don't need that one. We may need R squared, but we definitely need these coefficients. Those coefficients, this should be so simple on the test. You have to know that the top one is B0 and the bottom one is B1. Okay, and then you just have to fill it in. So if we start filling it in, it equals B0 plus B1 or minus B1, depending on what it is. And this is X, and this is Y. We already determined X and Y back up at the top of the problem. You could go back and you could look at that. But X is always here. It's always... right next to the slope is kind of in reverse order there, the way you put it in the equation. So that's distance. We had distance flown was X. And it's to predict the airfare. And we put the hat on it. If you forget the hat, that's not going to be that big a deal, but you should be able to write the equation from that. Okay? You also could figure out X here and Y here. Okay? Another place you can figure out Y is it calls it the dependent variable, so Y is also there. Any questions? All right, now R squared is 48.2. So I didn't want to squeeze too much on this page. So this still goes, what is the correlation between the two? Well, we know R squared is 48.2. So first, make sure you create and make this a decimal. If you don't make it a decimal, you will not get it correct. So take the square root. I'm just going to use the other calculator because this one takes a little longer. Take 0.482. And take the square root of it. Oh, where's the square root sign on this thing? Is it even on here? Right above the... Oh. Okay, so we get 0.694. Now, don't forget that you need to go back and look at the graph because it's like an algebra problem. If I were to take the square root, it could be, R could be positive 0.69 or R could be negative 0.69. But if you put both, you're going to get this question wrong. It's 1 point. have to go back and you have to look. And typically, I usually put a -1 on the test. I'm not trying to be tricky, but this one's positive. So the answer for this one is positive. So that's not the right one. You wouldn't even have to write that and cross it off or anything, but you have to know when you take a square root in algebra, you have to do that. Okay. Now, I don't think I have, well, let's see. I don't think I have one like C on there, but we're going to do it. We didn't actually put that on there. If I do have it on there, I'll probably eliminate that question on the test, but we'll learn how to do it. If the correlation between a father's height and his 16-year-old son's height is 0.7, find the following. What's the explanatory variable? Well, who came first? The father. And what's the response variable? The son's height. What's X, what's Y? Which one makes more sense? If they were interchangeable, you could have either, but usually in a question like that, we're going to have one that makes more sense. Now, if the father's height is 1.4 standard deviations above the mean, what would you predict about the son's height? It says here that the correlation is 0.7. So this is something I didn't have in the notes. We'll talk about this. If you convert it, this would be a z-score. If you convert one of them to a z-score, if you multiply the z-score times the correlation, you get what you would predict for the other value in terms of its standard deviation. So 1.4 times that is 0.98. So we would predict that the son's height is 0.98 standard deviations above the mean. So it may appear on the test, in which case I'll probably just eliminate that on the test tomorrow because I didn't go through that in any of the notes, but it's not a difficult concept. All right, number 5, a correlation between two variables, x on y, is r is negative. There's a negative there. Notice the slight negative, negative 0.77. Sometimes when I type and I use the Word document, the negative maybe is really small. We reverse the variables and we do y on x. The correlation is going to be negative 0.77. If you switch the variables, it doesn't change the correlation. Why? The relationship between the two variables ends up being the same. All right? Number 6. Okay, now this is the one where we have a couple of equations. B0 equals y bar minus B1 times x bar. I'll put these on the board tomorrow during the test. It's fine. We usually have a formula sheet. If somebody is doing this at home for some reason, then you can have the formula sheet, or I would put it in email, in case somebody's doing this remotely or online or something like that. But B1 equals R times S of Y over S of X. Y's over X's, that's always, it's the change in Y over change in X, but that's what a slope is, change in Y over change in X, but it's times the correlation. Okay, now, what we need to figure out is we need to figure out what's X, what's Y. The College Job Placement Office collected data about students' GPAs and salaries. Students' GPA is going to help predict their salary. What you get in college helps predict your salary. At least that's the sense of what we should be doing. The mean GPA. Now, we've got a lot of stuff. It's up to you how you do this, but the mean GPA, since GPA is X, and that's the mean, this one is X bar. With a standard deviation of 0.4, that 0.4, that's S of X. That's the standard deviation of X. Starting salaries have a mean of 47,200. That's your Y bar. With a standard deviation of 8,500, that's S of Y. And the correlation, R, is 0.72. You have everything you need to build your equation. Okay, so what we need to do is we need to put these in. Now, in the lesson, what you usually start with is B1 because you need B1 here in this equation in order to be able to do that one. So B1 is R, 0.72, times S of Y. So S of Y, we look for that. That's the standard deviation of the Y variable over S of X, which is 0.4. And we calculate that. So we grab our calculator. If I do mess up, somebody please correct me. Don't let me keep doing it wrong, but I get 15,300. Is that what you agree with? Okay. So now we need B0. Remember, that's B0, not BO, because that would stink if it was BO. All right. So we have S of Y. No, we need Y bar. Y bar is 47,200. Subtract B1. Now remember, if B1 happens to be negative, that would be a negative negative. It would turn to a positive. It's just basic rules of algebra or arithmetic, really. And then times X bar. So X bar is 2.9. So we put this in. You get these equations on the test, yes. So this gets us 2830. Now, if you do this, I usually make this worth 4 points, usually. So if you did get those right, you're good. The last 2 points are for putting them in. So even if you did get these wrong, you can usually get maybe 3 or 2 points yet. But we would want to make sure, since Y is salaries, this is where we're going to put it in. Y hat equals B0 plus B1X. So salary prediction equals 2830 plus, now be careful, see, this is plus B1, this is minus B1. A lot of students get messed up. Make sure you're using the correct equation. Yes, I usually give you all 3 of these equations on the test. They are on a formula sheet, so I'll either hand out the formula sheet or I'll just put these on the board. 15,300 times GPA. Okay, getting that in context.
So let's say you mess the variables up, would you get them all wrong then?
If you mess the variables up, you would probably get half the credit as long as you do everything right. So no, you don't get it all, but realize which one is the better predictor variable. I mean, GPA is going to come before your salary numbers. Okay?
Yeah.
Question?
Is it BO or B0 plus B1 times X or just X bar?
Times X. This is X, so whatever X was, so the X is the student GPA. X bar is the average of that. So to build this, you need the average and the standard deviation of different things to build the equations here. But then this X and this Y are just what X and Y are, what we're trying to work with as the variables.
So if it just says the mean or the average, that's when you know it's Y or X bar.
Yes. Yep. When it says the mean or mean or average and then standard deviation, that's your X bar and your S of X and then your Y bar and your S of Y. And you should have those 5 pieces: S of X, S of Y, X bar, Y bar, and R. Okay? Pretty good? Okay, let's just make that a video, and I'll do this.